Rohit is from Natural Language Processing Lab. They have large lab. And Rohit, what you doing in the lab? Something with language? Something with processing?
Yeah, language processing, machine translation mostly.
Machine translation. So, some difficulties? No. Wait. You get the image. What's that? What is it? Don't. Okay. So dark side. Oh, Pink Floyd. Okay, so let's welcome our speaker, Rohit Dholakia. Yay!
So this is the work that I've been doing with my advisor, Sarkar, in the Natural Language Lab, and I work in machine translation. And we'll talk something about machine translation, but I won't trouble you with hairy math equations because that's really boring. So I'll tell you what machine translation is not. So we don't write grammars like sitting in a dark room and trying to find which word follows which other word. And we don't make dictionaries, we don't hire linguists to make grammars for us. And generally we don't even know the language which we are translating from. We do know English, but if you ask us about prepositions or verbs or adjectives and some gotchas, then we don't really know that. So when we talk about language, it doesn't mean that I can speak the language which I work in, but generally we use a lot of math. So what we do have is a lot of statistics, probabilities. These days, because of so much data, we need to be good at systems, which we are generally not good at. And yeah, of course, we have lots of writing of code. So what is the assumption that we start with when we have machine translation? We assume that we have lots of data. So all we need is data of some form which we call parallel data. I'll tell you in a second what that means. So if we assume that we have some data and then we apply some machine learning and other math stuff to give you the translations. So that's the only assumption we have. So if you don't have data, then we pretty much cannot do machine translation. So what is parallel data? So parallel data means that suppose you have an English sentence A, then a parallel French sentence would be this one. So this is how are you in French. So if you have same sentence in two languages, we call that parallel data. But then one or two sentences is not enough. So to give you an example, French is the most studied machine translation language, and we easily have 2 million parallel sentences in French from the parliamentary proceedings. So every year UN records all the minutes of the meeting and releases it, and that's like 2 million parallel sentences. So, and French translation is pretty awesome. So if you go to Google Translate, they're doing really well with French. So that goes on to show the unreasonable effectiveness of data in the case of machine translation. So we give us lots and lots of data, and what we do is we tell you how they translate between two languages. So what do I work on? I work with Haitian Creole, which is not as fancy and as famous as French or the other European languages. Haitian Creole is spoken in a tiny country called Haiti, which had a huge earthquake in 2010 January. In the whole world, less than 10 million people speak it, and there is a reason it's called Haitian Creole. Haiti is from the country, but Creoles are a different kind of language. We'll come to that soon. So the question you want to ask yourself is that can we use machine translation during times of crisis? So if a disaster happens in a country which is God forbid, not so prominent as the European ones, then can you use machine translation to translate the things that people are asking for and then provide help and relief faster? So after the Haiti earthquake, there was an organization set up called 4636. It was a free phone number where you could send your message in Haiti and then people would give help to you. But it was in Haitian Creole and nobody understood Haitian Creole. So you had to hire a team of linguists and manually translate the messages. Within 5 days, Microsoft and Google released their MT systems, but that did not perform so well because Haitian Creole is kind of a complicated language. It has its own grammar, which is mixed from several languages. So after this effort, the data was released in 2011, and everybody asked themselves if you could set up machine translation systems on the go, like instant systems, not take so many years to set it up. Well, what kind of problems do you have if that happens? So you have less data. So Haitian Creole has hardly any data. We assume that we have some data on the internet written in Haitian Creole, but we don't have that. Then there are morphological issues because the data is kind of complicated. The language is derived from several languages. The other problem is domain. So when you talk about earthquakes, the messages are of a certain kind about relief and disaster, water, food, and generally you have news, and in news these Kardashians are quite famous. So the domain issue is there. You train on something like news and then you expect us to do well on earthquakes. That's kind of difficult. Also in case of disaster, so if you take Haitian Creole, the messages were ongoing, so it was not like you had all the data at one go. So you kind of accumulate the data step by step. And there's a high cost of mistakes. So if the guy says he's in the south and you say that he's in the north, then yeah, you kind of don't provide the relief. So you cannot afford to make so many mistakes when it comes to these kind of cases. And these problems make it much harder to do instant machine translation. So what is our aim? So our aim is to make translation better for something like Haitian Creole. We think that if we can make it better with less data, then we can do it for even other languages like those in Sudan, so whenever the dictator leaves. But we need data. So this data was released in 2011 and it was only 17,000 SMS. That is it. That's the only domain data we have. So from 2 million we have come to 17K. So now our aim is changed. So we want to still improve, but only with 8% of 2 million. Yeah, so that was kind of bad. So the thing is that we have less data, the domains are different, the language is more complicated, and we have out of vocabulary words because of less data. So the problem is that with all these things, the quality degrades exponentially in machine translation. So we need to fight those things. So why is it called a Creole? So Haitian, the country of Haiti was a colony conquered by the French long time ago. So what happens is in these kind of islands, it's somewhere near West Indies. So it had an African influence, but also because French people were ruling it, it has a French influence. So what happens is that it's a combination of 2-3 languages. So there are many kinds of Creoles. There are some even in Quebec. There is one in Mauritius, there's one in Haiti, there's one in other countries. So the key thing here is that Haitian Creole has French as one of its components. So an initial idea that we had was that we will use French to go from Haiti to English. So we'll go from Haiti to French and then French to English. We'll use that, we'll publish, and I'll graduate. But there was an issue with that there was no data from Haiti to French. There is no, I mentioned parallel data, there is no parallel data from Haiti to French. And the other thing is French to English is all parliamentary proceedings, which is again very, very different from SMS. And Haiti French is nothing. So I have no way to go from Haiti to French. And even if I had a way from Haiti to French, there is no way I have SMS from French to English. So if you think of this triangle, I am using 3 different ways of going on the triangle. There is one SMS, there is no way, and then there is Parliament. So we were again stuck. So now our aim changed again. So we want to improve, but we have 8% of the data. We have noise because of the French, and the domains are totally different. But the good thing was that we had a few lines of data. We had like 1500 lines, and we tried various ways. I can tell you some of these ways, but it's kind of hairy. So I'll tell you what happens. This is called triangulation. So here what we do is we want to go from Haiti to English. So we have one table which is like sort of a dictionary which says which word in Haiti goes to which word in English, and then we have some probability associated with it. What triangulation does is that it says that, well, let me go from Haiti to a set of intermediate languages, which in our case is French, and then finally I'll go to English, and I'll combine all these small tables and make a big table. So now I have one direct system from Haiti to English and one of these combined systems, which we do by triangulation. So we tried that. The good thing was that we got more data in the form of triangulation, but the bad thing was that because our domains are so different, we did not get any appreciable improvement. Other thing we tried is bootstrapping, which again was something similar. So what we thought is that why not take all these 2 million French sentences and translate it to a pseudo form of Haiti, and then try to combine it to the direct system. But again, one of the main problems which we have is noise. That because of those parliamentary proceedings, we are trying to translate things like we have no food, water in terms of parliament, where they talk about sessions and resumptions and parties and fights in the European Parliament, which is kind of civilized but does not help us at all. And then these are the two methods which we use in machine translation. One is phrase-based, where you take phrases from each sentence and then translate them. And this is something I've been working on since the last 2-3 weeks, which is a new form of machine translation, but it's not very scalable. So it finds phrases in a very hierarchical form. So each sentence in Haiti becomes a huge hairy tree, which is then translated into English. We have some results. There is something called BLUE, which is used to measure the accuracy, and I'm getting about 0.4 improvement, which is not so bad. If you get something like 0.7, it's considered pretty good, regardless of language pairs. So we're still working on it, and we hope to have some results with this. We have a lot of hopes on this approach, because what this does is this represents the dependencies between the phrases in the language. So in English, a noun is modified by something else, and sometimes in English you have 2-3 modifiers. This way of modeling the process of machine translation automatically learns these things, which is not done by this one. And we have the hope that SMS, which is short and which is noisy, which also has spelling mistakes, it will automatically learn how things are getting mapped. So yeah, that's the status of where we are. I've been working on this only for 4-5 months now. I joined pretty recently. So these are the problems which we're having. We have slight improvement, the domains are poles apart, the SMSs are kind of weird. It's just like English, where you use abbreviations like BTW and other stuff. So even in Haiti, after getting struck by the earthquake, they have many words for a single word. So sometimes it is in the whole form, sometimes it's in a shortened form. And we have to automatically learn that this is an abbreviation for something else, which is kind of hard in this statistical approach because of less data. So the gist is that Haitian Creole is a low density language. It's not spoken by many people, so we don't have much data. Noise is a huge problem for us, because when we go via French, then we add all these phrases which don't really matter. And on the other hand, everything is in terms of probability. So if you think that probability of 1 is the complete mass you have, then you're trying to assign some of that mass to different phrases. If you have noise, then what happens is you assign that mass to things that don't really matter, and you give some importance to noise, which in turn comes back to bite you. And the other problem which we have is domain adaptation. You have SMS which you want to improve, but you're trying to improve it with something which is very clean, like parliamentary proceeding, and that doesn't help you much. It's promising because if we can improve it for something like Haitian Creole, then we are sure to improve it for something like Mauritian Creole. And then if you think about Great Britain, there is an area called Welsh, and Welsh people speak a different language, which is kind of derived but still different. We think that if we can improve it like this, then we can also improve it for other languages which have a little correlation with something like French, but not much. So French influences Haitian Creole, but in the form of grammar, like the word order is the same, like subject, verb, object, but there's no vocabulary overlap. So Creoles, their genesis is kind of different. They borrow things from various languages, but not in the form of vocabulary. So a K becomes a C and a T becomes a B. Those are the kind of problems which we've faced. So French is helping us, but not something which can be published. Yeah. So do you have any questions in Haitian Creole or English?
Okay, so let's go.
So when you talk about the like the training data, right? So you said that from IDIN to English, there are like last parallel data, right? But I think like because the data you have is all for the during the earthquake, so right, it's collected during the earthquake. So I guess people usually sending messages like asking for help and food and like water or something. So I guess unlike like from English to French, you got millions of data because you almost include everything you speak daily or in a text. But I guess for Haitian to English, you got less data, but they're only part of their vocabulary, right? It's like.
Yeah, but so are you saying that even 17K is enough to learn about?
Probably, I think probably you can still learn some
Yeah. The problem is you could have, so if you had cleaned the SMS and then told us that, well, these 6 words are the same word with some spelling mistakes because of the nature of the way people message, then we could have still learned it. But the thing is that because we don't really care about how we're learning the grammar, we assume that we have enough data that all these math will tell us which word corresponds to which word. Then if you had lots more SMS than 17K, then we could have learned it, but just for the SMS. So the problem is that Haitian Creole as a language is quite complicated. So if you told us that, okay, you have 17K French SMS to English, then the whole game would have been different, because we have some idea about how to deal with French. So French also has accents, and then these accents have rules of the way they keep changing, and sometimes you use an umlaut, sometimes you don't use an umlaut. So we already have some idea of how to reorder things, because for example, if you take Japanese English, they have a different word order. So if you say IBM bought Lotus, in English, in Japanese you say IBM Lotus bought, but we already know that. So we reordered the sentence that way, because we had a lot of Japanese English data and we saw that a length of 3 here corresponds to a length of 7. But these are the kind of small things which we don't learn when you have less data, and then our accuracies go down the drain.
So you want? Okay, let's thank our speaker. And that's it, our second day is finished. Yay! Now please help me to collect the stuff, which includes